Hi there. In today's session, we are going to look at bar charts, reading off bar charts, drawing some bar charts, and then we'll have a look at dual bar charts also. I'm going to start with reading from bar charts. The main thing we need to be aware of with bar charts is that the length or height of each bar is what represents the frequency. So it is the length or the height of each bar that we are interested in. Here's an example one. So here's a bar chart, and this shows the number of hours of TV watched by someone in 1 week. Okay. So we can see on a Monday, there was 1.5 hours of TV that was watched. On a Tuesday, a little bit less, they just watched 1 hour of TV. On a Saturday, that was the highest amount of TV watched. That was in between 2.5 and 5, so we've got 4.75 hours of TV watched. Okay, so remember, we are very interested in the height of the bars. That is what is going to tell us the frequency. If we look at question A, on which day did the person watch the most TV? Well, we look for the highest bar, which is highlighted as Saturday. So it was Saturday was the day which the person in this bar chart watched the most TV. We're looking for the highest bar. Question B, how many hours of TV were watched on a Wednesday? So we have a little look at the Wednesday bar and we look at the height. We read off onto the y-axis, which is representing the number of hours. That tells us that on Wednesday, 4 hours of TV were watched. Question C, on which 2 days were the same amount of TV watched? So again, we're going to the bar chart. We are looking for the heights of the bar chart, and we want 2 bars which have equal height. Monday and Thursday are of equal height. You can see that highlighted in red on the bar chart now, Monday and Thursday. So Monday and Thursday are the 2 days when the same amount of TV was watched. Question D, how many hours of TV were watched altogether that week? So that means we need to find the total of the frequencies added together. So we need the height of each bar added together. So we've took the information from the bar chart, from the heights of each individual bar, added them together to tell us that there is 19 hours of TV watched. A few things to notice in the bar chart is, of course, we label our axes. We need to keep things appropriate. We need to keep things accurate. So we've got the day on the x-axis and number of hours watched on the y-axis. Notice that the scale is very appropriate. It goes up in a consistent manner. The gaps between the values are consistent, so the scale is very appropriate. If we look at the x-axis, one thing to notice about a bar chart is that the widths of the bars are all exactly the same. So there's a consistent width of 2 squares for each bar. That also is true for the gaps. The gaps are always a consistent width. In this example, each gap is 1 square. And that is very typical and needed in a bar chart. The widths of the bars need to be consistent, as does the width of the gaps. Okay, let's have a look at another bar chart. This time it's a horizontal bar chart, so we are very interested in the length of each bar. The length of each bar is going to tell us the frequency. Essentially, it works the same as example 1. We just have horizontal bars rather than vertical bars. This bar chart shows favorite sports of a number of people who were asked, or a number of people who were surveyed. Which was the least popular sport? We look for the sport which has the smallest length. So that would be rugby. In this case, you can see from here that only one person said rugby was their favourite sport? B, how many people choose tennis as their favourite sport? We have a look at the tennis bar. The length ends here. We read off the axes. 2 people. Which 2 sports were equally popular? We look for 2 bars of equaling height. Football and golf have equaling height. For both of those sports, 5 people said that that was their favourite sport. Question D, how many people were surveyed altogether? How many people were asked altogether? We look at the length of each bar to find the frequency of each bar, and then we add them all together to get the total amount of people asked. And in this survey, there was 30 people who gave their favourite sports. Again, look at the set out of the bar chart, equaling widths for the bars and equaling widths for the gaps. Axes are labelled accurately and the scale is nice and accurate as well, going up in a consistent amount. Okay, let's move on to drawing bar charts. If we're asked to draw a bar chart, we're always presented with a frequency table, a set of data. This table here shows the number of different cars, or the number of cars of different colours in a car park. So we can see from the table that there was 16 grey cars, there was 19 blue cars, there was 6 green cars, and so on. We're asked to display this in a bar chart, so we need to illustrate this data visually. At first, we need to draw out some axes, making sure that the numbers go up evenly. So what it's mentioning there is we need to ensure that our scale is appropriate. If we're representing 1 by 1 square, that's great, but we need to make sure that is consistent for the whole axis. We can't change the scale somewhere throughout the axis. It needs to be consistent. I've labelled my axes with colour along the bottom. As I mentioned on the previous few slides, we need to make sure that the bars we're going to draw are of equal width. For grey, it has a frequency of 16, so I've drawn the bar with a height of 16. It has a width of 3, and there is a gap of 1 square. So notice that's going to stay consistent as I go to draw my second bar. Red, a gap of 1 square, and then a width of 3 squares for the red, which has a height of 7, which is represented by this 7 in the frequency table. Go ahead and add on the yellow column, the blue column, and then finally the green column. So we've used the frequencies, we've used the totals in our table, which correspond to the heights of each bar to complete our bar chart, making sure widths of gaps and widths of bars are consistent and equal in width, and also our scale and axes are accurate and appropriate. Okay, let's have a little look at dual bar charts. So this helps us to present 2 bits of data side by side. The word dual meaning 2. Okay, so this time we've got some data, but we've got 2 sets of data. How many adults visited a small zoo on certain days, but also next to that, how many children visited a small zoo on certain days. We can present both of these bits of data on the same bar chart. Okay. Just like in the previous example, we need some nice, accurate and labeled axes. The highest value in my data is 58, which is why I've made sure my axis goes up to and slightly over 58, so 60 was an appropriate amount. My scale is very consistent. Every 1 square is represented by 2 visitors. Okay, I'm going to go ahead and draw on the bars for Monday's adults, which has a height of 56, and Monday's children, which has a height of 46. So we have a gap, and we have width of a bar of 2, width of a bar of 2. Notice with a dual bar chart, because we are representing the children and adults both visiting on a Monday, there is no gap at this point. We will be leaving a gap before we move on to the Tuesday data, but the Monday data is plotted on the bar chart without a gap. If I go ahead and add the Tuesday data, 26 adults, 50 children. Frequency is represented by the height. No gap between the adults and children's data, but there is a gap between Monday and Tuesday. I'm going to add on the Wednesday data, add on the Thursday data, and finally add on the Friday data. So we can see that the bars have a consistent width of 2, the gap is consistently 2. There's a gap of just 1 at the beginning of the bar chart. This is sometimes allowed because it's at the beginning of the data, just creating a small space to make sure it looks visually pleasing. All the other gaps are consistently of 2. So we've presented a dual bar chart, 2 bits of data on the same bar chart. With a dual bar chart, we'll also need to add in a little key just to make sure that we can distinguish between the data we are plotting. So in my example, I have colored the adults in purple and the children in orange, and a little key there explains the data so we have a bit of context. Okay. Sometimes when we're given some data, we might be presented with a list of non-numerical data, or what we could call qualitative data. In that case, we would need to take that data and put it into a frequency table before we can go ahead and draw the bar chart. So at this point, we could use a tally chart. So we can tally up the choice of people's favorite ice cream flavors. Okay, so you can see from here that there has been a survey and a lot of people have suggested their favorite ice cream flavor. If I wanted vanilla, if I look through the non-numerical data, I've got 1, 2, 3, 4, 5, 6 people who said vanilla was their favorite flavor of ice cream. If I wanted to represent that in a tally chart and therefore find the frequency, it would look like this. Remember, for the first 4, we have some vertical lines, but then for the 5th value, we cross the gate and put it into a bundle of 5. So this, along with this extra 1, represents a frequency of 6. If we count up how many people said that strawberry was their favorite ice cream flavor, again, we'd come with a total of 6. If we have a little look for chocolate, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people who say that chocolate is their favorite flavor of ice cream. If we want to present that in a tally chart, we have a bundle of 5, a bundle of 5, and 2 singles, giving us a frequency of 12. So just remember that when we're tallying, it's 1, 2, 3, 4 vertical lines, and then across the gate for the 5th to make a bundle of 5. If we go ahead and finish the tally chart, you can see there that there is 4 people who said mint was their favorite ice cream flavor, and 2 people said another flavor. Okay, so now I have the frequencies of each flavor. If I add them all together, I find that there's a total of 30. So therefore 30 people were surveyed, 30 people were asked what is their favorite ice cream. Okay, so now it's time for a task for yourselves. You'll notice that this set of data is the same data we were dealing with on the previous slide. I've now given you an extra bit of information that the 30 people surveyed were actually girls. So 30 girls gave their favorite flavor of ice cream. I've also added another set of data here where some boys were asked to also comment on their favorite flavor of ice cream. Okay, remembering at this point you have the ability to pause the video, and for your task I would like you to produce a bar chart for each set of data. So I would like a separate bar chart for the girls and their favorite flavors of ice creams, and a separate bar chart for boys and their favorite flavor of ice creams. Once you've completed those two, I would also like you to combine the data into a dual bar chart. So altogether, you're producing 3 accurate bar charts. Could you pause the video now and have a go at that task? Okay, welcome back. I'll just talk you through my solutions and you can have a little look at my bar charts. Okay, so here we go. For the girls' data, I've placed them into a bar chart here. Vanilla having a frequency of 6, along with strawberry, that is vanilla and strawberry being of equal height. And you can see chocolate is the most common. There is 12 girls who preferred the chocolate ice cream, and 2 girls preferred another flavor of ice cream. Notice that the scale on my vertical axis is very consistent. Each gap on my screen is represented by 2. I've also labeled my axes to give a bit of context to the question. I've added a little bit of color just to make the bar chart a little bit more eye-catching and a bit easier to distinguish between the bars. For the boy set of data, I've done exactly the same. I've took the frequencies and I've added them to a bar chart. My axes are nice and accurate. They are labeled. My gaps for bars and gaps for, sorry, my width of bars and my width of gaps are very consistent, very accurate, producing a nice bar chart. Okay, if we have a look at this bar chart, you will see that there's no colors on the bar. So all the mathematical information is there. We've got the heights of the bars, which relate to the frequencies. However, we could present it like this. So you can see it's the exact same data, presented the exact same way, apart from I have colored in the bars. Okay, so I'm just highlighting the fact that adding a bit of color can make the bar chart a little bit more pleasing on the eye. The color itself does not add any meaning or any mathematical value to the data, to the information, but what it does is it just makes it a little bit more eye-catching, a bit more visually pleasing, and it means that the differences between the bars visually are a bit easier to interpret. So the color doesn't add any mathematical information, it just makes the data a little bit easier to interpret. When we go ahead and combine the data, you may have wrote the data side by side, so it looks a bit like this. So we're still plotting the same bars. We have the totals for girls, the frequencies here, the total for boys, frequencies here. And if we go ahead and draw a bar chart, it would look something like that. Notice that there is a little key on the side here to distinguish between girls and boys, and your bar chart should look something like this. It might not look identical because you might have used a slightly different scale or slightly different widths, but one thing that needs to remain the same as mine is the heights of your bars will have to relate exactly to the frequencies in these columns here. Okay, very well done. If you were able to produce 3 good, accurate bar charts, then that is fantastic. You've shown a very good understanding of interpreting and drawing bar charts.